So, exactly what this title says, we are going to learn how to find the slope of a position time graph that is not linear. Because what you guys have seen in the new unit is that the position time graphs that are not linear is going to be a little bit difficult to find the slope. So we're going to have to learn a new trick graphically so that we can figure that out. So, let's go ahead and get started. So I'm going to draw a little position time graph here, and it's going to be simple. It's going to be something curved up like that. Alright, so what we're going to do here is we're going to get average slopes in smaller and smaller intervals around one particular point, and that point is going to be right there at 2 seconds. So that's what we are trying to do. We are trying to find the slope at 2 seconds for this position time graph, so that way we can see we can see what the velocity is at 2 seconds. Okay, so what we gotta do is pick 2 points. So I picked 2 points, and I'm gonna find an average slope between those 2 points. Right here at the top, that right there, that is actually at 3 seconds, and it went off the screen, unfortunately, but that's supposed to be at 9 meters. Then this point over here, that is at 1 second, and it is at 1 meter. So we are going to find the slope using those numbers here. Alright, so the slope, remember, slope is your change in vertical distance over your horizontal distance, but in physics we call that the velocity of this slope. So really it's our change in position over our change in time. That's what this delta x and that delta t mean, change in position over change in time. So this is what we talked about in class on Thursday. Nothing new, you're just finding the slope. So let's go ahead and find the slope. So those are our numbers here. So our final position is 9, and see, our final position is 9, our initial position is 1, and then our final time is at 3 seconds, and then our initial time is at 1 second. So all we're doing is simplifying that whole thing into one number, and that should give us the velocity. So our average velocity we calculate here is 4 meters per second. Okay, if you look at the graph, that slope that we drew, this line right there, the solid line, it's not exactly that accurate to this point here, because it doesn't even really go through that point. So what we're going to do to try to get something closer is we are going to find another slope, but we are going to use a point on the graph here and here so that it's closer to the point we're looking for. Okay, so let's go ahead and do that. So I'm going to erase all that, erase everything on the graph, and then what I'm going to do is, since we were at 1 second and 3 seconds, I'm going to move one tick over in both directions. So I'm going to do one at 1.5 seconds, and then I'm going to do one at 2.5 seconds. I don't have time to talk to you right now. Alright, so here we go. We're going to do the same old thing again. So we got 1.5 seconds, and so we got 1.5 seconds there, and then we got 2.5 seconds here. And this is where some estimation is going to have to come in here. So the position right there is about 2.5. Looks like it's about right there. Right here it looks like it's about 6.5. So our final position is going to be 6.5. Our initial is going to be 2.5. And then our times are 1.5 and 2.5. Okay, so let's go ahead and calculate that slope out. These are our numbers here. 6.5, 2.5. That's our change in, this is our change in position right here. And then that and this are change in time. So let's do it. So So when we calculate that, we get about 3.75. So that's pretty close to 4 meters per second, which is what we got for the last estimation. So let's do one more that's even closer. So we're just getting closer and closer to the slope at 2 seconds here. So we'll do one more, and if we get 4 or something close to 4, then we could probably be pretty confident that a slope right there, tangent to that line, tangent to that point, is going to be 4 meters per second. Okay, so let's do one more using those 2 points. So what I'm estimating those numbers to be for x is, if we look at our graph right here, that point right there looks like it's just under 5, so I'm going to estimate that to be 4.75. This point here that we're going to look at looks like it's just under 3 or right under 3, so I'm going to estimate that to be 2.75. And the times we know, they're just halfway between 1.5 and 2, and then between 2 and 2.5. So we got 1.75, 2.25. Alright, so those are my estimations. And then our slope, if we do everything right, should be 4 or something close to 4. Alright, so we get 4. So that means, in conclusion, the slope right there, right on that point, is 4 meters per second. So that means if I drew a tangent line through that point here, so right through that point, and I got the slope of that line, it would probably be 4 or something pretty close to 4. Cool. Okay, so that's essentially how you got to do it. This is what we're going to work on in our worksheet so that we can try to get a velocity time graph from this graph. So here's our conclusion. When finding the slope for different points on a position time graph, so position time graph that's curved, if we want to find it at any point, we need to find smaller and smaller intervals. So we're going to have to do some estimating to make this work. Alright, hopefully this helps, and if any point you did not understand what was going on, then go back through the video again and see if your answers to your questions can be found. Thanks for watching, guys.